All right, welcome back. This was the problem you had to do on your own. Let's go ahead and do it together. We're looking for the 6 trig identities. So we need sine theta, cosine theta, tangent theta, as well as cosecant theta, secant theta, and cotangent theta. I do need to have all 3 sides to be able to do this. So I'm going to need to use my Pythagorean theorem in order to find this third side. So this is 6 squared plus 8 squared equals, excuse me, c squared. I'm having a rough time with these little, like, extra little marks on this particular today. I don't know what's going on. Anyway, that's 36 plus 64 equals c squared, which is 100 equals c squared, and I know that if I take the root of both of those, that's going to be 10. We've got another nice little Pythagorean triple here. So, sine is 6 over 10, opposite over adjacent, or excuse me, hypotenuse, which we can reduce to 3/5. The cosine is adjacent over hypotenuse, so that's 8/10, which we can reduce to 4/5. The tangent is 6 over 8, which we can reduce to 3/4. Now the cosecant, secant, and cotangent are just the reciprocals of those. So cosecant is 5/3, the secant is 5/4, and the cotangent is 4/3, because I can just flip what I know the tangent is to find the cotangent. All right, and so those are my 6 trigonometric identities. If you have questions, make sure you ask them. Otherwise, let's look at some special angles. So we have 2 types of triangles that you would have learned about in geometry that occur frequently. One of them is the 45-45-90 triangle, and the other one is the 60-30-90 triangle. And excuse me. These triangles occur frequently when we're doing trigonometry. They're part of what's called the unit circle, which we'll see a little bit later. But for now, we want to look at some of these side lengths. So we learned in geometry that these side lengths for our 45-45-90 are 1 in root 2, and that for a 30-60-90, the short side is 1, the hypotenuse is 2, and the long side is the square root of 3. So for each of these angles, 30, 60, and 45, their sines, cosines, tangents are commonly used for this thing called the unit circle. So we're going to just measure them right now, and that's going to, and so we'll have this as a little reference that we can use for later, because we're going to use these angles often, the values for these ratios often. So the 30 degrees, right, you'll notice is opposite over adjacent, or excuse me, opposite over hypotenuse. So that's 1/2. The cosine of that is adjacent over hypotenuse, so that's root 3 over 2. And the tangent is the opposite over the adjacent, which is 1 over root 3. But you remember, we got to simplify that because we can't have a root in the denominator. So we multiply both sides, top and bottom, by root 3, and we end up with root 3 over 3. Now, cosecant, secant, and cotangent are the same thing, but we flip them. And again, you've got to do a little bit of root simplifying to get these. So I'm just going to put them down here. You have to do this process for them. Where I'm not going to do it on each one, so we're just going to write down those copies. So sine, cosine, tangent, cosecant, secant, cotangent for a 30-degree angle. That is a reoccurring thing that will show up often. Okay, 45 degrees are like this. The sine, you'll notice, is going to be opposite over adjacent. That's 1 over root 2. But again, remember, we're not allowed to have that root in the denominator, so we multiply top and bottom by root 2, which gives us root 2 over 2. Cosine is the same thing, root 2 over 2. Tangent is 1 over 1, because opposite over adjacent gives us 1, so that's 1. If you flip these, the cosecant and the secant are going to be the same. They end up both being root 2. And the cotangent flipped is just 1. Now, the 60 degree, you're going to notice, will be very similar to the 30 degree. It's just we're going to switch some of the things around. On a 60 degree, the sine is root 3 over 2. Notice that that's different from that one because there was the cosine on the 30, but it's the sine on the 60. Which means that the sine is going to flip also, 1 over 2, because that's what our adjacent side is. The tangent will also switch, which means that our cosecant, secant, and cotangent will also flip. 2 root 3 over 2, or excuse me, over 3, 2, and then root 3 over 3. Okay, so we have this list where we came up with these from the special right triangles, okay? So keep this handy while we answer the next question, okay? So we have this triangle. Notice that it is 30 degrees, okay? So we're going to find the value of x for the right triangle shown here. So we need to find this x value. And so what sides do we have? What's the trig identity we're going to use? Notice we have adjacent and hypotenuse, which we know is cosine. So here we have cosine of 30 degrees. And I know that the cosine of 30 degrees is x over 8. Right? But remember, if we go back to this previous page, I know what the cosine of 30 degrees is. The cosine of 30 degrees is root 3 over 2, which means this is root 3 over 2 equals x over 8. And now we can cross multiply to solve for x. So this is 2x equals 8 root 3. And then solving for x, I divide both sides by 2, and I get 4 root 3. So this side length is 4 root 3, and I know that because since the cosine 30 is root 3 over 2, I can cross multiply to get the x by itself. So let's put this information together to solve a right triangle, okay? So solving a right triangle means that I'm going to find all the sides and angles for the triangle. Okay, so we're going to do that. Notice that I've been given one angle, and I know that this is a right triangle. So I need to find this angle, this side, and this side. Okay, so let's do the angle first, right? Remember, the interior of a triangle is going to equal 180. So I know that if I take 180 minus 90 minus 28, I'm going to get this last thing. What is wrong with my pen? So 180 minus 90 minus 28. Well, 180 minus 90 is 90. 90 minus 28 makes 70, 62. So that is a 62 degree angle right there. Now I need to find these other sides. And I find them using the right triangle trig we did on the previous problem. So let's find this hypotenuse right here, okay? So I have a 28 degree angle here, and I have this side length. So this is adjacent and hypotenuse. So if I take the cosine of 28, because that's adjacent and hypotenuse, equals 15 over c, I can then cross multiply to find the c. So 15 times 1 makes 15. Cosine 28 times c makes cosine 28 times c. And then to get the c by itself, I'm going to divide both sides by the cosine of 28. And now that's calculator work to find that c value here. So this is 15 divided by cosine of 28, which is going to give us 16.99. So that number right down there is 16.99. Now, I'm not done because I still need to find this a value. And so I could do it the same way. Use this angle, opposite, adjacent. So I could use the tangent to find it, or I could use this angle and go opposite, hypotenuse, and use the sine. Either way works, right? I could do tangent of 28 equals a over 15, or I could do the sine of 28 equals a over 16.99. Either way, we're going to get the same answer, right? And either way, we're just multiplying by the denominator to find out what that value is. So 15 times tangent of 28, that's calculator work. 15 times tangent of 28, it's going to give me 7.98. You can do the same thing over here and do 16.99 times sine 28, and it's going to give you a very similar answer. There's going to be a slight rounding error, but it still gets you down to the 7.98. Rounding error occurs further down. But there it is. This side right here is 7.98. And now this triangle is solved because all sides and angles for the triangle have been solved for. All right, I've got a triangle for you to solve back on your notes. Please go and do that, and we will see you in the next and final video. Bye.